Welcome back, I'm Mr. Harper Smith. This is another day of Harper Math. So today we're going to finally look at integrating underneath the curve, finding out the exact value of an area under the curve. So for instance, from -2 to +2, what would be this total area under the curve? Well, it's definitely not a circle, definitely not an oval. It's some other funky shape. How do we find the exact area? Before, we've played around with the trapezoidal rule, we've played around with left and right approximations. We've gotten really close. We haven't figured out the exact area yet on something like this. So let's try an example. We want to know what is the area under the curve from -2 to 2. So we write what is the area under the curve from -2 to 2 of the equation x squared, that's what this equation is, dx. Well, we know this symbol means to integrate, so let's integrate the equation. This is going to become x cubed. Now 3 times what is 1? 1/3. Okay, 1/3. We want to integrate it from -2 to 2. Okay, so let's take our 2 and plug it in. So 2 cubed is 8. 8 times 1/3 is 8/3 minus this bottom number. The bottom, -2 cubed is -2 times -2 times -2, which is -8 over 3. All right, well, what's 8/3 minus -8/3? Well, that's the same as adding. This is going to work out to be 16/3, which is roughly, well, not roughly, it is 5 1/3, okay? That is the exact area under this curve. Exact, okay? If you look, you have 1 there, 2, that's about 3, maybe 4, 5, and 6. If you're using the trapezoidal rule, you're not going to get very close. But using this method, we get the exact value of the area under the curve. Let's try another problem. All right, let's try another problem. Here we have the graph -x squared plus 4. We want to integrate it from -2 to 2. So basically, what is this area under the curve? Okay, looks similar to the last problem we did, but it's kind of flipped upside down. Well, we integrate this. This is going to give us -1/3 x cubed plus 4x. We need to go from -2 to 2. We go through, we plug 2 in. That gives me -1/3 times 8 plus 4 times 2, because 2 cubed is 8, okay? Minus, let's see here, -1/3 times -8 plus 4 times -2. And let's just stop right here and look at what's actually happening, okay? So this is the equation that modeled the graph that we were trying to find the area under, but then we integrated it. When we integrated, we got this equation here, okay? This -x cubed graph. -1/3 x cubed plus 4x to be exact, okay? And what we are doing here is we're taking f of 2 and subtracting f of -2. That is exactly what is happening. So all that we're doing is saying, all right, what's the high point? What's the point at 2? What is the point at -2? Well, it's down here, and let's subtract them. What is the difference in the height? Okay, the difference in the height here and the difference in the height down here is the area under the curve for our original graph that we were working with. That is all that integration is doing. That's all that we're doing when we're finding the area under the curve, is we're just trying to find the difference in this graph of those two values, okay? We'll try another couple here in a sec. But anyway, we go through, we solve this. At 2, let's see here, that's -8/3 plus 8, which would give us, let's see, -8/3 is technically 2 2/3, 6, 5 1/3. So this is 5 1/3 minus, let's see here, minus -5 1/3, which gives us 5 1/3 plus 5 1/3 is 10 and 2/3. That's the total area under the curve there, okay? Let's try another one. Here you go, let's try another one. So on this one, we want to integrate from -2 to 2. It's not always -2 to 2. Those just happen to be the examples I keep doing. Next time we'll try some different numbers. -2 to 2 of the equation x cubed plus 4x. All right, well, step one, we want to integrate. Now, just looking at the graph of this equation, we might guess that it's going to be somewhere around 0. Because here it looks like you got a positive something. Here you've got a negative something. When you combine those, it's probably going to be close to 0 is my guess. But let's find out. So, this is going to be x to the 4th, 1/4, plus, what's that going to be? I'm sorry, that should be a minus. The equation I did that should be a minus. Minus 2x. Okay, 2x squared. So that integrates to, we want to know from -2 to 2. What is the area under the curve? Okay, well, we plug in 2, it gives me 1/4 times 2 to the 4th power, whatever that is, minus 2 times 2 squared, minus 1/4, -2 to the 4th power minus 2 times -2 squared. Let's see, 2 to the 4th, 2 times 2 is 4, 8, 16. So 16 divided by 4 is 4, minus 2 times 4 is 8, minus, that's going to be 4, it's going to be 8. -4 minus -4, ooh, what's -4 minus -4? 0. Sounds about what we were expecting. Another thing to look at is down at the graph of the equation that we just integrated into. Remember, we're just looking at the difference in the end and beginning point. That's all that we're really doing when we're looking at these graphs. What's the difference? There is no difference. They're both at -4. So in this equation, the total net area under the curve versus over the curve, over is the same. There's no area. It is 0. Okay, here's a fun one. So we have the graph of 1/2 x, and we want to integrate it from 0 to 8. So basically, what is the area under the curve from 0 all the way to 8? Well, if we want to find this area, doesn't it kind of look like a triangle? It does kind of look like a triangle. Well, let's figure out what the area would be if it is a triangle. The triangle's 4 tall, it's 8 wide. 4 times 8 times 1/2 would give us 16. Okay, that should be the area under the curve. That is the area of the triangle, so that should be the area under the curve. Let's see if it works. So, this becomes x squared. 2 times what is 1/2? Sorry. We are, 2 times what is 1/2? It would be 1/4. Here we go. We want to go from 0 to 8. Well, when you plug in 0, you get 0. You plug in 8, 1/4 times 8 squared minus 1/4 times 0 squared. That's basically what we're saying. Well, that's 64. 64 divided by 4 is 16. Minus 0, 16. Okay. Hey, we got the same answer as just doing it geographically. Okay. You get the same exact answer by just integrating. Same exact answer. It's kind of cool. All right, I want you to try this next one. All right, here we go. This one is your job to figure out. What is the area under the curve of 2x plus 3 dx from -4 to 4? Let's try. Pause the video. All right, you should have paused the video. You should have had the answer figured out. It's now time to talk about what the answer is. So, we want to figure this out. Let's first integrate. That gives me x squared. 2 times what is 1? 2 times 1 is 2. Sorry, 2 times what is 2? 2 times 1 is 2. So the answer there is 1. We just leave it like that. We've got plus 3x. We want to go from negative 4 to 4. Let's do the 4 first. 4 squared plus 3 times 4 minus negative 4 squared plus 3 times negative 4. You gotta be really careful here. If you don't put the parentheses around the negative 4, it might tell you that the answer is negative 16, just for this little piece. Really, it should give you a positive 16. Here we go. We've got 16 plus 12 minus 16 minus 12. Let's see here. That gives us, what is that? 4. 28. What's 28 minus 4? 24. If you got 24, give yourself a pat on the back. Good job. Woo-hoo-hoo. All right, I want you to try this one. What is the area under the curve of the equation 1 divided by the square root of x from 4 to 9? What is that area? Give it a try. All right, you should have paused the video. You should have your answer by now. I did forget the dx there. I am sorry. Okay. Well, first off, can we integrate if it's just 1 over square root of x? No, we can't do anything if it's just square root of x's. We don't know how to do this. So we need to convert this into an exponent. So this is the same as integrating from 4 to 9, 1 over x to the 1/2. Awesome. We're going a step in the right direction. We don't know how to do it when x is in the denominator, though. We need to get x into the numerator. All right, well, integrate from 4 to 9, the equation x to the negative 1/2 power. Okay, we can do that. We're going somewhere now. Perfect. So, we're stepping in the right direction. Let's see what's next. Next, we're going to integrate. So we're going to add 1. That gives me x to the 1/2 power. 1/2 times what equals 1? The answer is 2. 1/2 times 2 is 1. So this is the integral of this. Well, 1/2 power, what does that mean? What does that possibly mean? It is just a square root. So it's 2 times the, you can kind of see, 2 times the square root of x from 4 to 9. Well, this one's going to be pretty easy. I'm going to take this, I'm going to throw it up here. We've got the 9, 2 times the square root of 9, minus 2 times the square root of 4. Square root of 4 is 2, square root of 9 is 3, so 2 times 3 minus 2 times 2, that's 6 minus 4 is 2. Ta-da! Okay. So the total area under this curve from 4 to 9 is 2.